standard layer network architecture for high-speed rail transportation facilities. In modern railway transport facility, there is demand for broad range of novel onboard services addressing various end users in particular applications for passengers, critical services, and emergency services to stakeholders engaged in trade operation, as well as complementary services services related to optimization of train operation. These services are collectively denoted as FRMCS services. The prototype network and associated deployment to facilitate train operations and the services. Considering the FRMCS service definition is developed, the project evaluates the performance of FRMCS service over the Patras 5G facility that a testing for infrastructure deployed and operational railway environment. In this, in particular, it tests demonstrates representative business performance and critical services. The architecture proposed should ensure that services are provided while the train moves through Patras city center through heterogeneous technologies, establishing high capacity, low latency connections at a high speed mobility. High capacity is needed for the farmer services in order to provide high quality of service to passengers, whereas for the latter low latency ultra reliable connections are needed in order to transmit data obtained from various sources in real time to the train operations, driver and control center. Always complementary services related to optimization of train operation. Those services are collectively denoted as FRMCA services. The protected network and associated deployment to facilitate the train operations and the services concerning FRMCS services definition is developed. The project evaluates the performance of FRMCA service over the Patras 5G facility, a testing infrastructure deployed at the operational railway environment. In particular, test and demonstrates a representative business performance and critical services. At lower lies a train and board network. This consists of several compute and network elements, all interconnected by fiber network. The postponed and board network comprises a 10 Gbps Ethernet LAN with the SDN capable switches connecting sub-6 and mmWave wave antenna module to be installed on the roof of the train, and the software based 5G NR and Wi-Fi APS to be placed inside the train. The train internal wireless part of the onboard segment comprises of SW based solutions for 5G NR and Wi-Fi provided and aggregate environment argumenting the overall capacity of the network and controlled through a single centralized CU. The CU can be instantiated as a VNF and edge data center and manage multiple heterogeneous distributed units DUS that integrate the radio level characteristics of the base station. At this point, a compute node is also necessary to deal with the handover management, though it can also act as potential CEO of the de- disaggregated 5G NR cell. Moreover, cameras are interconnected and applications related equipment realizing the critical service to be transported from the train to the control center located in the cloud. Here, for example, train at a train station, locally railway premises under train stations, local cloud facilities, remote facilities. That is, figure 5G architecture for testing FMRCS railway services. So, here GNP, 5GG, 5GC, MF, 5UPF, multi hope wireless transport, mmWave, sub-6, compute switching facilities, train station, multi hope wireless transport, mmWave, ISP, internet, 5GC, FM, UPF, CCTV, MCPTT, mobile TV streaming, remote facilities, local cloud facilities. At the second level, various technology are used for the track-to-train connections. A heterogeneous wireless network is deployed operating in the sub-6 GHz frequency band and mmWave units featuring beam tracking capabilities. At the third level, the interconnection of the track-side APS to the core network is achieved through multiple point-to-point wave part that provide up to 10 Gbps capacity as shown in the map of figure, but also through fiber links. Finally, a full 5G base station unit with MEC capabilities is assumed to be located at the train stations and is connected through mmWave PH to the control center. Then 5G mmWave track to train connections. Sub 6G HZ sub 6G HZ 6 gigahertz mmWave sub 6G 6 hertz sub 6 hertz 5G NR sub 6 6 GHz access only through one track side unit. Handover between different technology units. Here, here handover between different technology units. mmWave sub 6 gigahertz. Okay. Here integrated. Here is handover between different technology units. Sub 6 gigahertz, sub 6 gigahertz, sub 6 gigahertz access only through one track unit. Network is slices for service delivery and rail transportation environment. The existing telecommunication infrastructure deployed at the railway environment includes several versatile communications technologies and different public and private network deployments to serve the demand for versatile services from various end users. These practices are pushing existing network deployed in the railway environment to the limits, make it difficult to guarantee total coverage for all services along the extensive railway tracks and are also leading to optimal utilization of resources, and slow service deployment. The standard successing GSM or Future Railway Mobile Communication System (FRMCS) addresses the current network inefficient and meets requirements uh, of the aforementioned services. It is considered a key enabler for rail transport digitalization and reflects uh, the technology neutrality and network services logic of 3GBP, 4G, 5G standards tailored to the specific environment services requirements and deployment challenge of the railway environment. In particular, business services refer to communication and broadband connectivity services provided to passengers present in railway facilities, that is, at the rail stations, platforms on board. These services include infotainment, digital mobility, travel information services, etc. The the performance services category includes non-critical services related to train operation, including infrastructure monitoring and maintenance services. Usually, these services are deployed and consumed inside the railway facilities environment. So, the service deployment will consider this uh, aspect, like for example CCTV services for supervision of the railway tracks quality and provision of maintenance when needed will be used as example. Critical services are related to train operation, movement, railway automation and operation control systems, trackside maintenance, emergency and safety services, etc., and involve information exchange between various usage stakeholders. Example, railway infrastructure operators, train operators, railway staff, railway first responders, etc. Usually, these services are deployed and consumed inside the railway facility environment. So, also in this case, service deployment will take the aspect into consideration. Example of these are mission critical boost to top (MCPTT) and mission critical data. Example between the controllers at the train operations and the driver, onboard staff, etc. The onboard hosted services correspond to three different slices which are initiated concurrently, providing the required network substrate to the hosted services. These three services correspond to the three different slices. First one is an EMBB slice for providing onboard users with a high-speed internet connectivity and video streaming services, and EMBB and URLLC slice for providing a low latency and a high bandwidth connection for the track monitoring service to the cloud. The URLLC slice for providing low latency communications for MCPTT service needed for the operation control of the railway system. E2E network architecture extension for digital mobility service related KPIs. 5G UK test network has integrated multi-architectural multi-rate designs in order to enhance current telecommunication services for a number of futuristics digital mobility use case demonstrations incorporating the different applications APP1, APP2 and APP3. These applications have been defined according to the requirements set by the Digital Mobility UG Bristol as follows. ABB provides a immersive media and VR services to travelers arriving at MSHED.